Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we want to continue to analyze this frame under step number 3. Step number 3 is Sidesway frame. So the diagram shown right now is original frame. So this frame is actually by applying the principle of superposition, we divide the frame into two systems. The first one is properly restrained frame, which we analyze under step number 2, table number 1. Okay, and for table number 2, we will analyze Sidesway frame. Sidesway frame. So the Sidesway frame that we are going to analyze is actually this one. Okay, the frame is subjected to R prime. This frame is subjected to R prime, and due to R prime, the frame is tend to move to right direction. Okay, look at the column and always remember we measure the deflection. We measure deflection or we measure displacement for column which is perpendicular to the member. So inside this frame, we have like this A, B, C, D. Okay, the column is AB. The column is AB and CD. BC is beam. Beam will just follow wherever the column move. Okay, so we have to focus on the delta which is occurred for AB, for member AB, column AB and column CD. Okay, and always remember that it is perpendicular. So what we just need to do is we have to sketch, okay, the new position of B and new position of C, because A is fixed, D is fixed. So due to Sidesway, B and C will move to new position. Okay, so we can illustrate like this. So B will move to new B position. So this is 90 degree. And C will move to new C position, also 90 degree. Okay, so the new position of B is here. This is B prime. And the new position of C, so this is B prime, new position of B after Sidesway. And the new position of C after Sidesway is this position. Okay, 90 degree towards column. Column AB, 90 degree is like this. And towards, okay, for CD, okay, due to Sidesway, moving to right direction. So we will have like this. It is straight line. Okay, 90 degree. Okay, and then we just need to, so this is C prime, and we just need to join from B prime to C prime. So this is B prime. So for C prime, B to C prime, we just need to join these two dot. Okay, so this is the illustration of the beam due to Sidesway, where what most important is we have to identify where is the delta for each member. We have member AB. The perpendicular of member AB is the delta for AB, and the delta for AB we name it as delta 1 prime. Delta 1 prime. So this one is delta 1 prime. Perpendicular to the member AB. Perpendicular is delta. Okay, that is for AB. So now look at member CD. For member CD, perpendicular to CD is horizontal because CD is vertical. CD is vertical, perpendicular to CD is horizontal. Okay, and since member CD is the third member in this frame, so the delta for member CD we label as delta 3 prime. Member AB is member 1. Member BC is member 2. Member CD is member 3. So we will use delta 1 prime for AB, delta 2 prime for BC, and delta 3 prime for CD. Okay, so now beam has beam also move to new position, and from this diagram we can see that there is a vertical displacement occur, and this vertical displacement is actually occur in beam BC. Okay, if previously when we analyze this type of frame, due to R prime, okay, due to okay, this point will move to this point, and this point will move to this point. There is no vertical movement. There is no vertical deflection. Because beam is horizontal member, we have to measure the vertical displacement, But in this case, we can see that there is a vertical movement. The vertical movement is actually measured from the lowest to the highest position of B prime and C prime. So this is actually the delta for beam. Okay, delta for beam, because beam is horizontal, the delta is vertical. Beam is horizontal, delta is vertical. Actually, what most important here that I want to highlight is when we combine this, okay, AB, the delta is this. AB, the delta is this. So this is delta 1 prime. Okay. Column CD, the delta is horizontal. So this is the horizontal. Okay, and this is delta 3. And beam is horizontal member, the delta is vertical. Okay, and this is delta for beam. Okay, so means that we can combine delta 1, delta 2, and delta 3 prime, delta 1, delta 2, and delta 3 prime as one triangular in the frame. And this triangular is actually located here. Okay, this is actually this. Okay, because this will be equal to this, and this is equal to this. This one equal to this one equal to this. So what most important is not this diagram. Most important is this. Actually, you don't have to draw this. Because the most important is this triangular. Always remember Always remember this is belong to A, B, and this is perpendicular to AB. Okay, this one is belong to BC. It is vertical because beam is horizontal, and delta 3 is CD, for CD, because column CD is vertical and the displacement is perpendicular delta 3. So we will use this delta 1 prime, delta 2 prime, and delta 3 prime whenever we calculate the FEM due to Sidesway. And the formula to calculate FEM, due to delta is 6EI delta. So we use prime, so we put prime here, over L squared. Okay, 6EI delta over L squared. Okay, so in this analysis under step 3A, under step 3, so all we label as prime. So because we are referring to diagram D, remember diagram D, so it is subjected to R prime, so the delta is delta prime. And due to an inclined member, AB is inclined, so we will have delta for all members. We have delta for beam as well. Delta 2 is vertical, and vertical displacement belong to beam. So when we analyze FEM later on, what we should do is we will apply all this into the formula. So the formula to calculate FEM for member AB, which is equivalent to BA, is 6EI delta 1 prime over L squared. This is 5 squared. This is the formula to calculate FEM for member AB. And don't forget, don't get confused between FEM due to external loading and FEM due to delta, because of the behavior. Both FEM AB and BA must have the same sign. Due to external loading, we get one negative, one positive. But due to delta, we get both AB and BA has the same sign. Okay, this is the formula for AB. AB, member number 1. So the delta that we use is delta 1 prime. Okay, for FEM for member CB, BCCB, BCCB, okay, it is 6EI. Don't forget member BC has 2EI, so we have to times by 2 here. Okay, delta 2 here. Beam, we use delta 2. Beam, we use delta 2, so this is divided by 6 square. Okay, this is the formula whenever we calculate FEM for member BC. For member BC, it is beam, we use delta 2 prime. Delta 2 prime. Okay, next is member CD, FEM. For member CD, okay, is 6EI. CD, member number 3, so we use here delta 3 prime. L is 9 square. 9 square. So these are the 3 FEM formula, the 3 FEM for the frame, member AB, member BC, and member CD. Okay, don't forget, the first, we have to assume the first FEM, because the delta is unknown. The delta is unknown, and under step 3A, we actually assume FEM. under step 3A, we actually assume FEM. And we just need to assume, we just need to choose one member to assume the FEM, and the other two members, we will calculate based on the ratio. Okay, let's say we choose member AB. We choose to assume FEM for member AB. Okay, for member AB, the moment that we assume is negative 100. Negative 100. This is the value that we assume. And don't forget the negative we use here is for the behavior. It represent this. Okay, original is like this. After Sidesway, okay, means that the new position is this. This is the new position. The new position, and the moment. So we the fixed end moment, push this and push this. Okay, and the direction is negative. The direction is negative. So this is actually 100. This is 100. This is 100. And this 100 is negative because of the behavior. Because of the behavior. So this is A. This is B. This is B prime. Okay, A, B. Okay, the negative that we assume based on the behavior. Okay. Okay, now from this assumption, negative 100 for member AB, we have to calculate the FEM for member BC and for member CD. And in order to do that, we have to change this delta 2 prime and this delta 3 prime into delta 1 prime using this triangular. We have to write the relationship. We have to write relationship between delta 1 and delta 2, and we have to write relationship between delta 1 and delta 3. This is just simple mathematical calculation using trigonometry. So in order to do that, we have to have the angle in this diagram. We have to have the angle. Since this triangular is located here, this triangular is located here, and we can calculate the angle actually from so this is 5 meter, this is 3 meter. So this will produce the triangular, which we can calculate the angle. Okay, so this one is 4, which we can calculate the angle. So we can calculate, okay, the angle. So it is, okay, arctangent. So it is 4 divided by 3. It is 4 divided by 3 arctangent. So it is 53. So this is 53.13. Okay, so this one is the basic fundamental of mathematics, where from this diagram we should, okay, identify the 53.13 in the triangular. So from this, since this one is 90 degree, so what we get is this one is 53.13. So means that this is 53.13. So from this triangular, this is 53.13. 53.13. Okay. So this is important. We have to identify the angle so that we can write the relationship. Okay. So having this, we write the relationship. Okay, we write the relationship. If you want to write if you want to substitute delta 1 prime into FEMBC, so we have to have relationship between delta 1 and delta 2. Delta 1 and delta 2. It is just the cosine. The cosine, 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 and for delta 3 and delta 1 is sine. Okay, so using that relationship, so we get cos 53.13 and we get sine 53.13. Okay, for cos 53.13, cos is delta 2 over delta 1. Delta 2 over delta 1, cosine, cos. Delta 2 over delta 1. This is mathematics, yeah. So this is delta 2 prime over delta 1 prime. And sine 53 means delta 3 over delta 1. Delta 3 over delta 1. This is delta 3 over delta 1. Okay, so what we get after this is, okay, we get delta 2 prime is equal to delta 1 prime cos 53.13 and delta 3 prime is delta 1 prime times sine 53.13. Okay, so now we have changed delta 2 in terms of delta 1 and delta 3 in terms of delta 1. So we substitute into the formula. So in order to do that, I just want to again use the table. So in the table, I list here the member. So FEM. We have member AB, we have member BA, ABC, BC, and CD, FEM. Okay, the formula, based on the formula, okay, the formula is 6. The formula is 6. Okay, the formula that we just written. Okay, this is 6. EI, it is delta. It is delta. It is delta 1. Delta 1 for AB. Delta 1 for AB, and AB, the member length is 5. The member length is 5. Okay. For member BC, okay, for member BC, we use delta 2. We use delta 2 prime, and for member BC, we have to times with 2. Okay, and the length for member BC is 6 meter. Okay, and then for member CD, okay, for member CD, it is 6 EI. For CD, we use delta 3. For CD, we use delta 3. Okay, here is delta 3. Length is 9. Okay. Okay, now we have to substitute. Okay, we have to substitute this delta 2 delta 2. So we change this to this is delta 1, delta 1 prime cos. It is cos 53.13, 53.13. Okay, and the other one is sine. Okay, this is 6 and 9. Okay, so this one is sine. Delta 3 is sine. We use sine. So sine 53.13. Okay, so okay. Okay, next is we have to calculate 6 divided by 5 square in terms of EI. Now we have changed all to EI delta 1. We have to change all to EI delta 1. So after this, we can find the ratio. Okay, so it is 6 divided by 5 square. It is 0.24 EI delta 1 prime. And then 6 times, we forgot to put 2 here. This is 2. Okay, it is 6 times 2 times cos 53.13. We have to divide by 6 square. 6 square. We get 0.2. So this is 0.2. And another one is 6 times sine 53.13. We divide by 9 square. So it is 0.06. 0.06. That is the ratio. That is the ratio in terms of EI delta 1 prime. Okay. And the assumption is for member AB, which is equal to negative 100. Negative 100. Okay. But careful about this because we have to check the behavior. We have to check the behavior because member AB, the behavior is like this. Okay, this is AB, this is 90 degree. So the black is the new position. So the moment is like this. So this is negative. This is negative sign. Okay, for member CD, column is like this, vertical. Column is vertical. Okay, 90 degree is like this. Okay, the black line is the new position and the moment will apply like this. So again, it is a negative sign. It is negative sign. Okay, for beam, always remember that beam is horizontal member. Beam is always horizontal. Beam is always horizontal. And the delta is vertical. The delta is vertical. So the new position of beam is this. Okay, new position of beam is the black one. So the moment, so means that we have to push this point and push this point so that it will move back to horizontal. So for beam BC, it must be positive. So the moment shown here is positive. Okay, so that is why for the for the FEM for member BC, it should be positive because of the behavior. Okay, we have negative for AB because we refers to this moment direction. It is negative direction. Okay, and for member CD, again the moment, the fixed end moment acting like this to counter back the new position to go back to its original position. Okay, and for beam BC, always remember that beam is a horizontal member. Beam is a horizontal member, and the delta is in vertical direction. So the beam after Sidesway is look like this. This is the beam after Sidesway. Okay, so the curve, the incline is the new position. So we have to push. We have to push. Okay, we have to push this point, the 2 point push back to horizontal position, and the counter back moment is positive, is in positive direction. So we will get AB negative, BC positive, and CD negative. CD negative. So having this, we can use interpolation to calculate the value for BC and for CD. Okay, so using 0.2 and 0.24, it is 0.2. We divide by 0.24 times 100, we get 83.33 for FEM for member BC. So it is 83.333. 83.333, and okay, it is 0.06. 0.06. I check again. 6 times sine 53.13. We divide by 9 square 81. It is 0.06. 0.06. So to calculate the value, the FEM for CD, it is 0.06. We divide by 0.24 times with 100. So the interpolation, it is 25. It is 25. Okay, so the value that we get here is actually based on interpolation. Interpolation. After we actually use ratio to determine the value. Anyway, to in order to use ratio, we should change all in one term. We should change all in one term, because from the formula we will find that for AB we use delta 1 prime, for BC we delta 1 prime, for BC we use delta 2 prime, for CD we use delta 3 prime. So at this point we cannot use ratio. So because delta this 3 delta is not constant. So what we should do is we have to change all into one term. So we choose to use EI delta 1 prime. So we have to change delta 2 prime and delta 3 prime into delta 1 prime. So how we do this? We use the triangular representing here. Okay, this is delta 2, this one is delta 3, this one is delta 1. Okay. Okay, this is for AB, this is for BC, this is for CD. Okay, check where is the perpendicular. Delta 2 is always vertical. Delta 2 is always vertical because beam is always horizontal. Delta 2 is always vertical. Okay, so we have to change into one term. So we choose to stick to EI delta 1 prime. So we have to change delta 2 prime and delta 3 prime in terms of delta 1 prime. So we have to use the trigonometry to relate all this. Okay, we have to have the angle. One angle is okay, is necessary. So this one we determine as 53.13. 53.13 we get from. So that is why the understanding of Sidesway is very important. Okay, look at the original frame. Okay, original frame is like this. Okay, and we have to have this angle because okay, the triangular is located here, the triangular. So we determine this as 53.13 from, okay, 534. Okay, and then we get this as 53.13. So using mathematical fundamental, so we get this as 53.13. So that is why we get this as 53.13. So from this triangular, we can have a relationship between delta 1 and delta 2 prime and delta 3 and delta 1 prime, so that we can fulfill this table. So this table we produce in order to change all in one term. So after we substitute cos 53 and sin 53 into BC and CD respectively, so we calculate the value the value. So from the formula we get that AB is 0.24 EI delta 1 prime, BC is 0.2 EI delta 1 prime, and CD is 0.06 EI delta 1 prime. Okay, so now having this, the assumption is negative 100. The assumption is negative 100. So using interpolation, we calculate the FEM for BC, and we calculate the FEM for CD, and don't forget to include the behavior. So for the behavior, please draw the free body diagram, the diagram of the element, the member after Sidesway, and try to imagine the moment direction, the fixed and moment direction. Okay, so how we get 83.83. Actually, we will do interpolation, the simple interpolation like this. Okay, so we have 0.24, which is equivalent to 100. So if now we have zero point 0.2, so what is this value? So having this, it is just like this we times 0.2 times 100, we divide by 0.24. Okay, 0.24, so we get 83.33. We put positive because of the behavior. Okay, and normally beam will opposite. Beam sign for FEM will opposite with column sign. Both column will have same sign. Both column will have same sign. Beam will have opposite. Okay, for the Sidesway, both column A, B, and CD will have same sign, negative and negative, and beam will have opposite. So means beam will be positive. Okay, so same goes to member CD. To get 25, it is 0.06 divided by 0.24. Okay, it is just like this. So we have 0.24, which is equivalent to 100. So if we have 0.06, what is the value? So to determine this is actually equal to 0.06 times 100, we divide by 0.24. So this one is equal to 25. 25. Okay, this is the three value that this is the three value that will be used in table number 2. This is the fixed end moment. So we will write this value under at all position. For ABBA, we will use negative 100. ABBA is negative 100, no negative positive, both are negative. For member BC, we use BC and CB. BC and CB, we will use positive, positive, 83.333. And for member CD, the value is negative. So we will put CD negative, DC also negative 25. Okay, so this is how we actually analyze, or we assume FEM for Sidesway frame. And from the assumption, we actually use interpolation to determine the FEM for remaining for member BC and for member CD. And actually, this is one of the option that we can consider when we want to calculate FEM due to Sidesway. Of course, there is another option as shown in the textbook in how to determine the FEM. Okay, so inshallah we will meet again in the next video. We will continue step 3B, 3B to calculate the end moment for Sidesway frame. We will find the M prime at the end of the analysis. Okay, so we will meet again uh, in the next video inshallah. Assalamualaikum warahmatullahi wabarakatuh.